equation represents the change of corresponding to the enthalpy change of atomization. So for atomization, Jordan, can you actually tell me what is the definition for enthalpy change of atomization? Is the enthalpy change when? Sorry. Yeah. Move on.
Enthalpy change when one mole of gaseous atoms is formed from its elements, I think.
Yeah, gaseous atom is formed from its elements under standard state. Yeah, so we are talking about 1 mole of gas. Okay, this is 1 mole of gas, 1 mole of gas. Definitely B and D will not be the answer. Okay, so 1 mole of gas from the elements. Okay, from the elements under standard condition. So under standard condition, iodine is going to be solid or gas, Kenneth? We are waiting for you, Kenneth.
Why, sir?
Okay, can you actually tell me under standard condition, okay, group 17 here, F2 is going to be gas, liquid, or solid?
F2 solid.
No. Okay, I want you to take note here. Okay, this one we have discussed earlier. Okay, it's gas. Cl2 is gas. As you go down, okay, the melting point and boiling point increases. Therefore, Br2 will be liquid. Starting from I2 it will be solid. So even after that, S13 is going to be solid as well. Okay, so in this case, the best answer is going to be A or C. Kiara? Okay, the answer is going to be C because iodine is going to be solid, okay, in at 25 degrees Celsius, okay, according to the standard condition. Okay, so let's actually move on. Okay, for this question, probably I will start off like this. There are 2 enthalpies that I thought you must be exothermic, always exothermic. And there are 1 enthalpy that is always endothermic. I want you to actually recall on this now. Kendrew, can you tell me 2 enthalpies that's always going to be exothermic?
The endothermic, atomization.
Okay, Jordan, you can switch your device now. Okay, so endothermic is atomization. How about exothermic? James, can you tell me 2 enthalpies that's going to be exothermic?
Combustion.
Yes, combustion. Another one, I'll give you an idea. Acid and base, acid and alcohol.
Neutralization.
Yes. So these 2 enthalpies, they are always exothermic. So in order to answer this question, okay, which row is always correct? Yeah. So here, atomization is always endothermic. Therefore, they are always positive. Okay. So must be always positive. C and D will not be the answer. Now, for formation, they are not here. Okay, it means formation, they can be either positive or negative. Okay, so this one will be the answer. Solution also, they are not here. Okay, it means solution also can be either positive or negative. Okay, so the answer is going to be B. So this is all coming out from your MCQ questions. Yeah, so please actually memorize. Okay, now if you look at number 3, the equation for the reaction is shown below, and then they mention X here, enthalpy change is X. So I want you to actually look at this equation, okay, to form water, okay, to form water. And they have given 2 types of enthalpy here, formation, combustion, and formation. Yeah? So I want to actually find out, is this representing formation? Josh, is this equation representing formation?
Yeah.
Okay, define enthalpy of formation for me, Josh. Enthalpy change
the enthalpy change when 1 mole of product is formed from its elements at standard temperature.
So to be exact, 1 mole of compound, okay, 1 mole of compound is being formed, okay, from its elements under standard state. Yeah. So the term compound must be there, and that compound Okay, it's not specific like they must be gases. Like for example, atomization must be in gases. So in this case, the compound is still in standard condition. So water is going to be liquid. Okay, it is actually being formed from the elements, and those elements are under standard state as well. Oxygen is gas, hydrogen is gas, and everything is just fine. So this one can be categorized under formation, but I want to also check whether it is right. Is it right to actually refer it as combustion? Yeah. So Justin, can you tell me, can we refer this equation as combustion? What is the definition of enthalpy of combustion, Justin?
When one
Mole of
mole
substance. One mole
an
of
element
substance.
sorry. One mole of substance combust in excess oxygen to give compound.
Okay, in this case, which is there any one mole of substance being combusted with excess oxygen?
Yeah.
Which one is combusted? You can see over here, right? Hydrogen gas, one mole of hydrogen gas is combusted. Yeah, reaction with oxygen is combustion. Yeah, so this is going to be enthalpy of combustion of hydrogen. Yeah, so this one, okay, definitely can be also included as combustion as well. So A and B will not be correct, but since we know, okay, combustion is always exothermic. Okay, we already know it's exothermic. So the value of X must be negative, even though I know formation can be either positive or negative. Since it is representing both equations, okay, we cannot have positive value here if it is combustion. Yeah. So of course the value must be negative together. Yeah. So D will be the best answer for this question. Yeah. So here, okay, the next question is enthalpy change of formation. Okay, this one we defined earlier as well. Okay, so Erlin, can you tell me again very quickly the definition of enthalpy change of formation?
The enthalpy change when
One
one
mole.
mole of substance is formed from its elements under standard conditions.
Okay, please remember again, it's 1 mole of compound. Yeah, 1 mole of compound. 1 mole of compound being formed from the elements. So here, automatically D will not be the answer. Okay, that's 2 there. So of course, possible all this, okay, because 1 mole of the compound, but it must be formed from the elements. This is not the element of, okay, that is suitable. Yeah, nitrogen must be N2. Oxygen must be O2. Okay, so this one will not be accepted. If it is oxygen, yes, possible. Carbon is always solid, okay, possible. See whether it's balanced for B. I think it's balanced. Most probably this is correct. But I will also look at A. Okay, I know oxygen, okay, carbon. The only problem that I have over here is carbon is gas at 25. It's wrong. Yeah, carbon is always solid at 25 degrees Celsius. So therefore, the answer is going to be B. Okay, so you can see how they ask you questions on this. Okay, this one is I just included this question. Any reaction when you have A reacting with B, sometimes we do have a reaction what we call as reversible reaction. So we actually put double arrow, okay, forward and then reverse. Okay, let's say it's giving you C and D. The one going to the right is called forward reaction. The one going backwards is called reverse reaction. We will learn this later. Yeah. Now, in normally, if they don't tell us, it means if it's automatically forward reaction. If they just put like this is forward reaction. If it is reverse reaction, then C plus D to give you A and B. Okay, that's reverse reaction. So when you have this, yeah.
So basically, whether it's a forward or reverse reaction, depending on how they give the question to us.
Yes, okay, because not all reactions are reversible. Like for example, I'm very sure you have seen this equation last time. Haber process is a reversible reaction. Okay, but when you have a normal reaction, HCl plus NaOH, I bet you that you never seen any reaction that write a 2 arrow over there. Okay, so some reactions they do have reversible reactions. Yeah. So they can actually change from here to here. They can also change over there depending on the conditions. Yeah. So in this case, okay, they say it's a reversible reaction. They already mentioned. If you follow your normal way, okay, if it is going this way, okay, if it is going this way, we call it as forward reaction. Okay, forward reaction like normal. Okay, normally we just assume it's going to go like that. Okay, so this one will be your reactant and this will be your product. Okay, that is going to be forward reaction. Let's look at forward reaction only here. So this is forward reaction, this is forward reaction. Okay, let's actually look at B and C. Enthalpy change for forward reaction is 30. Is this enthalpy change is going to be 30 for this forward reaction, Jonathan? Is this endothermic or exothermic? Higher energy to lower energy. Delta H is?
Negative, right?
Negative. Heat is being released. Higher energy to lower energy, where the extra energy went. So it went out to the surrounding. So it's negative. And negative how much? Negative 50. Okay. So this is not going to be the answer. Okay. And then here also enthalpy change, they say it's also going to be 30. No, the answer that I'm looking for is negative 50. Okay. Now let's actually look at reverse reaction. Now reverse reaction is going to be slightly different. Okay. We have to look at the graph in a different way. Okay. It's going to be something like this now. The graph is going to be from here. Okay. Starts from here. Then go from here. So if you are not, if you're confused, A plus B supposed to give you C plus D. So of course, if you have C plus D to give you A plus B, then they will move from here to there. So if you want, you can actually put this as your reactant. Okay, and this is going to be your product for your reverse reaction. Okay, for your reverse reaction. Now it's just the way how you look at it. Okay, it's just the way of how you look at it. So here they say activation energy is 80. Let's actually see whether that is the activation energy. Activation energy is from the reactant to the top. So this is the reactant to the top. You can see it's 80. This will be the correct answer. But let's actually check for D. The enthalpy change for the reverse reaction, you see. If this is the reactant, lower energy to higher energy, what is your delta H for what is your delta H for reverse reaction?
Delta H 80.
No. From here to here, right? Delta H is always from the reactant to
Plus 50 to 50.
so it's going to be plus 50, yeah? So it's endothermic reaction if it is going to be reverse reaction. So this is also incorrect over there because it's supposed to be positive 50. So this one, okay, the answer is going to be A. I'm just introducing this earlier for you so that you can get ready for future, okay? But anyway, number 6, which reaction is endothermic? So in order to answer this question, okay, I want you to recall about endothermic reactions, okay, not the enthalpy, endothermic reactions, the one that we actually learned under endothermic. Can you give me 3 examples of endothermic reactions? Let's actually see, Dylan. Dylan, can you actually help me with 3 examples of endothermic reaction?
Decomposition.
I cannot hear you, Dylan.
Thermal decomposition.
Good. Okay, any kind of thermal decomposition is going to be endothermic reaction. Other than thermal decomposition, can you actually recall other examples? Maybe Annabelle, can you actually help out? Other endothermic reactions?
Not sure, sir.
Okay, Clienta or Rafael? Anyone who knows, you can actually help out. There are 3 endothermic reactions, if I'm not mistaken, that I have discussed.
Photosynthesis.
Neutralization.
Neutralization is always exothermic, Ashley.
Combustion, sir.
Combustion is always exothermic.
Photosynthesis.
Photosynthesis is an endothermic. What else?
Dissolving of ammonium salts.
Okay, any ammonium salts, okay, any ammonium salts, for example, let's say ammonium chloride with aqueous, it's also going to be endothermic. That's number one that I actually put in the past notes.
Sublimation.
HCO3
Citric acid.
and citric acid. Very good. Okay, this is going to be another example of endothermic reaction. Okay, please actually take note. I think, let me see whether I can find the notes. Yeah, I think this one. Okay, so you can see any kind of decomposition. Okay, this one, and photosynthesis. Okay, if any of the notes that you feel that you want to get it, immediately ask me after the class. I have it over here. I can just change it into PDF and send it to you. Yeah. So anyway, we'll come back to the lesson again. Okay, so we'll come back here. So I wanted to actually show you about something to do with thermal decomposition over here. Now, thermal decomposition, the one that I gave you examples, okay, will be when you have, for example, magnesium nitrate. Okay, magnesium nitrate, when you decompose, you get MgO plus NO2 plus O2. Another example that you can have for thermal decomposition, I think the one that I always mention, calcium carbonate, gives you calcium oxide plus carbon dioxide. Okay, these are thermal decomposition. Okay, now from here, is there any of the equation A, B, C, D that looks similar like thermal decomposition? Lindsay?
2 HBr to H2 plus Br2.
Yes. Why? It's okay, Lindsay. Raphael already answered. So Raphael, can you actually tell me, okay, the 2 HBr to give you H2 and Br2, why you categorize it as decomposition?
Because it's a compound being broken down to its elements.
Yes, you can see that the difference here, the same thing, you see, the compound is broken down into something else, yeah? Not necessarily must be elements, but it can be broken down into smaller parts, okay? So similar, it is broken down into smaller parts, okay? This is an example of decomposition reaction. So this decomposition reaction, if you understand this, that's the answer, okay? That's the answer. But, okay, if let's say, okay, over time you forgot about that, yeah, then you still actually can work out something else. Like, for example, I told you that one of the important equations in chemistry is Haber process, which is production of ammonia. This one, I even remember the enthalpy change of the reaction, which is going to be negative 92. So always remember, Haber process is always exothermic. Okay, so maybe that will be also helpful. Now, I know that this is going to be also exothermic. To be exact, why it is exothermic? Angela? Why I know that this C is exothermic? It's an enthalpy change of what? Yeah?
Combustion.
Very good. Okay, it's an enthalpy change of combustion. Combustion of what? Okay, but again, yeah, this one is, if you look at it as combustion, yes, but again, it's not enthalpy change of combustion because it's 2 moles being burned. Okay, so this one, to be exact, is 2 times enthalpy change of combustion. I hope you understand this. Okay, because it's not 1 mole being burned, it's 2 moles of sulfur dioxide. Sulfur dioxide is being burned. Yeah. This one, okay, this one is going to be formation of acid rain. Now, this is formation of acid rain is also exothermic. Okay, it's also exothermic. So you learn, okay, when you keep on learning new equations and so on, I think you just start to memorize and you get hold into it. Yeah. So this one is going to be,
Sir,
yeah. Josh?
can we use the concept of like bond breaking and bond formation here?
Actually, the concept of bond breaking and bond formation, right? You have to use that. Okay, you have to use that. But can you use that here? Actually, no, not really over here, Josh. Because when you look at concept of bond breaking and bond formation, you need to know the energy that is required to break, and then the energy that is required to form. Without that, those data, you cannot conclude that this is going to be exothermic and endothermic. But that concept is you can use that concept to prove that this is going to be exothermic or endothermic. That one we will learn later part. Okay, the next lesson that we are going to learn after today's lesson is going to be about the bond breaking and bond formation, and it depends on those values. Okay, why we can say that ammonia production is negative, why we can say it's always endothermic when it comes to decomposition. Okay, so that depends on the amount of energy required, because there is a difference with the amount of energy for forming the bond and breaking the bond. Okay, so can we use that concept? Yes, but not to identify whether they are exothermic or endothermic without the data. I hope it answers your question, Josh. Without data, you cannot determine that.
Sir, the energy for the energy for bond breaking and bond formation, are those also dependent on the conditions of the surrounding?
Actually, it's like this. Okay, if I just put it in this way, if I have A and B, okay, it's going to let's say I have like this. Yeah. N2 plus H2 to give you NH3. Okay, let's say this is 3. Now, in order for this reaction to happen, okay, the reactants, they need to actually break the bond breaking. In order to form products, okay, there should be bond formation. Okay, so what actually happens here is, okay, the bond between nitrogen and nitrogen needs to be broken. Okay, so it means that in order to break bonds, you need to take the energy from the surrounding. It means it's for breaking, it's going to be endothermic. Okay, for breaking is endothermic. The same thing, there's 3 moles of H2. You need to also break this energy. In order to, you need to break this bond. In order to break this bond, you need to also take energy from the environment to break. So this is going to be endothermic as well. Okay. Now, imagine the value of this is going to be, let's say I add all this energy and I get positive 50. Just take a random answer over here. When I add, okay, all those energy is positive 50. Now, I also need to form bond. Now, all the nitrogen, they are separated. So N and N, you have 6 hydrogen atoms. Okay. So they are going to form a bond with nitrogen. 3 bonds is being formed. Bond is being formed. Then this one bond is being formed. Okay. Now, in order to form bond, because do remember they have absorbed energy, they are vibrating. Okay, they are vibrating. They have energy. Now they have to actually go and form bonds. So where those kinetic energy goes, the kinetic energy goes out to the environment. Okay, so this is going to be exothermic. So it goes to the environment. This is going to be exothermic. Imagine for all these 6 bonds that is being formed. And I'm going to actually get the total energy, which is going to be, I just give you a random answer. Yeah. Let's say it's negative 100. Okay, because it's an exothermic. So if I ask you what is going to be the enthalpy change for this reaction, so what we need to do is we need to add the energy. So the energy is positive 50 plus negative 100. So total, I'm going to get negative 50. Now I can conclude that overall, this reaction is exothermic. So it means that your bond formation and bond breaking, the values depends on the values. We can actually identify that it's going to be exothermic or not. Okay, so we need to calculate. I hope this one explains. I think I already taught you about the next lesson already here. Okay, it's just a brief explanation. But Jordan, can you actually understand what I'm trying to say here? Okay, how about Jonathan? Can you understand this?
Yes, sir.
It involves bond breaking and formation. So if you look at any equations here, it definitely involves bond breaking and bond formation. But we do not know what is the exact value. Okay, but these values can be obtained from your data booklet. That is what we are going to learn later also. You need to calculate. Okay, but before you need to calculate, you also need to know that even you calculate some reactions, you can always tell it's going to be always negative. Okay, like combustion is always negative. Neutralization is always negative. Okay, decomposition is always positive. Okay, why? If they ask you why, simple. For decomposition, why is always positive? It means your bond breaking, your energy for bond breaking is always going to be higher than the energy that is released from the bond formation. That's the explanation. Okay, so it means it's very difficult to break the bond. Okay, so if you break the bond, after you form this bond, it's still going to be, okay, like for example, you still going to be extra positive values of the energy will be there. So it means that, okay, your bond breaking is more, the energy required for bond breaking is more compared to the energy released for bond formation. So it's always like that for decomposition. Yeah. So anyway, we'll just move on. Okay, I don't want to actually make you more confused. But again, you see here, this is similar question about enthalpy change of atomization of bromine. So atomization, so 1 mole of atom in gaseous form, okay, from its element under standard state. Okay, so here bromine is going to be liquid. Okay, we have actually go through earlier just now. Bromine is going to be always liquid. Therefore, okay, this answer is going to be C. And then the last one, yeah. Okay, the last one here, which one correctly described as enthalpy change of formation? Okay, formation must be 1 mole of compound being formed. Cannot. Okay, so if you want to form 1 mole of compound, possible. Okay, so we form the 1 mole of compound from the elements. Are they elements here? Definitely no. Okay, so the elements, these are the elements, and check they are under standard condition. The answer is going to be D. Okay.
Sir?
Yes, Josh.
For just now in number 4, why are atoms not considered elements?
Again? For
For
number 4.
4C.
Josh, I'm at number 4 now. So what's your question?
Why are atoms not considered elements?
Okay, why atoms are not considered as element? Because nitrogen alone, okay, they are elements. Actually, definitely nitrogen is element. But nitrogen under standard condition do not exist as N as element. So they are always in form of N2, always. So like for example, under standard condition, like for example for carbon can always exist like carbon as atom. Okay, but for nitrogen, okay, cannot. Oxygen cannot exist like O alone. Okay, they must be in O2. But helium can. Helium can be in atom. Hydrogen cannot. H alone. They will always, okay, become the more stable form, which is going to be H2. So it's actually got to do with your stable form. Okay, like for example, group 17. They are always going to be Cl2, Br2, okay, but not all of them. Later we will learn also. I think even when just now when I was explaining, you can see that I mentioned about F2. Okay, I mentioned about F2, Cl2, Br2, I2, and so on. But for S13, I don't actually put, sorry, S13 is 80, if I'm not mistaken, yeah. But for S13, I don't put like this because under standard condition, S13 do not exist in this way. They exist in this way, 80 alone, yeah. So this one, there are certain situations where certain elements, they behave in a more stable way. Like for example, 80 will be 80. Yeah. Iodine will be I2, cannot be I alone. Yeah. So that is going to be under that standard condition. Does it answer your question, Josh?
Yeah.
So it cannot be O, it cannot be nitrogen like that. Okay. And that is not going to be, you don't get gas nitrogen in form of N. There is no N gas. It doesn't exist. Okay, it doesn't exist. Okay, so that is actually the explanation for that. So now if I want to summarize this, okay, this activity, number 8. So I want you to actually I will ask some of you, please actually summarize what you learned from these 8 questions. So maybe we will start with Jennifer. Jennifer, what you learned from these 8 questions? Can we have some points?
Iodine as solid in room temperature.
Okay, maybe we do like this. Okay, maybe we try something different. Yeah, just hold on. Yeah. Have you tried near pot before? I think yesterday some of you asked me what is near pot. Yeah. Let me actually show share to you something. Just wait. Okay, just give me 2 minutes. Dylan, are you there? I think you are having internet connection.
Sir, just now I got disconnected.
Okay. Guys, I'm going to actually you check your chat box. I'm actually sending you a code. Please actually go click at that code. So I've actually put over there. Please write your name. Okay, I think when you get that code, I think they'll ask you to write your name or something. Then after that, I have what you have learned from those questions. So please actually write down for me. No need to actually write everything too long. Just one thought. Yeah, just write it there. One thought, you just write it over there. So we'll wait for you guys. Okay, I can see James, Jordan, and Rafael already there. Guys, I don't see anything over there. Okay, I do see people joining, but nobody posted over there. So you can see over there, share your thoughts and images here. So you can type over here and then click post. What you have learned, okay, from those questions, 8 questions. Okay, I can see okay, Ashley already pasted over there. Okay, please actually keep it coming. Learn that exothermic enthalpy change is negative, endo is positive. Okay. Formation of acid rain and Haber process is exothermic. Very good, Jordan. This is very good. What else? Okay. Iodine is solid at standard condition. Very good. Okay, we need to pay attention to the standard temperature before answering our answers. Okay, good. Keep it coming. Okay, not all 21 students are here. Okay, hurry up. Atomization is endothermic because it involves bond breaking. Yes, very good, Nevan. So very good observation over there. Okay, because atomization, it always involves bond breaking alone. Okay, so it's always endothermic. Okay, the states of matter, group 17 elements are at the states of matter are at standard condition. I think Jonathan maybe need more polishing over there. So the states of matter, group 17 elements. Okay, it means what we have learned. Yeah, so it's gas, bromine is liquid, and then I think iodine is solid, and so on. I think that is what you wanted to say. The certain elements can exist as atoms, some as diatomic. So also astatine is not diatomic. Good. I learned that neutralization and combustion are always exothermic and atomization is always endothermic. Okay. Later bit. Okay. Raphael mentioned thermal decomposition. Okay, with also citric acid, baking soda. I think Raphael is not barium hydroxide. It's actually reaction with aqueous. Okay, reaction with aqueous. This one, I think it's supposed to be water with ammonium salts are endothermic reaction. I'm not sure whether barium hydroxide with ammonium chloride are all endothermic. Okay, need to check. Okay, anyway, ammonium chloride when you have water, yes, it's an endothermic. So I learned that the standard enthalpy of atomization only involves element in their standard form. Okay, and then produces 1 mole of gaseous compound. Okay, it's not gaseous compound, it's gaseous element. Ella, yeah. So I also learned that astatine exists in monoatomic form. Yeah, decomposition is always endothermic. Yes, Angela mentioned about ammonium chloride plus water is an endothermic reaction. So I have all the 21 students, but I don't have 21 answers here. Hurry up. If there is any other things, you just put it over there. Kiara mentioned, yeah, atomization is always endothermic. Okay. I learned how to analyze enthalpy diagram in a reversible reaction. Yes, good, Annabelle. Photosynthesis, thermal decomposition, dissolving, okay, are all endothermic reactions. Very good, Lindsay. What else? Okay, we'll just wait for another 3 more responses, then we will move on. So this is actually Nearpod. Okay, this is one of the activities in Nearpod. Okay, so we will actually this one I find it very useful. Okay, very useful. We will try to use this more on when we do brainstorming. Yeah. So I learned about how to interpret the reaction pathway for reversible reaction. Okay, good, Dylan. We are still waiting. I don't think so. We have 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 only. Clienta mentioned about formation and solution can be both exothermic and endothermic. Okay, good. What else? Formation of acid rain is exothermic and photosynthesis is endothermic. Yeah, good, Justin. I learned to distinguish the part of enthalpy diagrams such as activation energy and enthalpy change. Good, Ellen.